Hello, and thank you for taking some time to learn more about Python and JMP integration. Please read the associated blog post if you haven't already. So you'll learn more about some of the basics that we're going to talk about today. A group of us, JMP SEs, have developed a series of blogs that are going to showcase the ease in which JMP and Python can be integrated to handle everyday tasks like data cleaning. In this video, we'll show you how to use the mouse and our eyes to find some potential outliers or move them from the data table. You will also see how to analyze for missing values, and if necessary, you might have to impute values as surrogates to see how any analysis would turn out if the data was not missing. Okay. JMP and Python have been complementary for several years now, and with the release of JMP 18, it is much easier to integrate Python analytics with the excellent data visualization in JMP. However, and I'm highly biased here, data cleaning in JMP is much easier than it is in Python for one very basic reason, and that's coding. As an example, we're going to go through a set of data over here. We're going to talk about going from JMP to Python. In this case, we're just going from JMP to Python today. And later blogs, you'll learn how to go from Python back to JMP as needed. Okay. The data set we're working with today is called arrhythmia, and it's in our sample data set. Chose it for the very specific reason that it has some missing data and some outliers that we're going to use JMP's capability to find them, and then also show you that you can do the same thing with Python. And Python will call the data table and generate the missing value report and the outlier report. All right, so with our eyes, if we look at distribution data in our mouse, now we've got looking at right away, if we look at height, it's got some potential outliers. Right, so, and this is in a univariate sense, so we're looking at the data one variable at a time. And that can be quite tedious. But overall, the idea is that you're looking for the data that's missing or that are potential outliers, and then you select it in the platform that you're working in, and then go back to the data table. And that data is actually selected in the data table, back in the data table, where you can then hide and exclude it, delete it, or do what you need to do to get it out of the way for future analysis. Now, I would say that in most cases, if you're using Python, if you delete these rows, I think that's the way to do it with outliers. But with JMP, we would never tell you to delete your data completely. So if you're going to do this and you're actually going to delete the data, then you need to save a copy of the data, the original data, so you can go back to that and then look at the outliers in a different way. All right. So that's in a univariate sense. If you look at it in a multivariate sense, we also have that set up here. All right, so we're looking at the data, and I'm going to pull a little trick here. I'm going to highlight the data, use my control key, and right click and go to rows, markers, graph marker size, and give some large. Yep. And now we can see those data points a little bit better. Let's go down to the height right here. And if we look at that, we can see that we've also got that data, and we can select the data in there just like we did in the associated distribution platform. Okay. The nice thing about the multivariate platform is you can see things a little easier for all the variables. There's another way to do that, but we're not going to talk about that today. And that would be the model-driven multivariate control chart. So that's using our mouse and our eyes to get there. From here, once we have the data set up, we could actually just go to send this data to a Panda data frame or a Python data frame, and I'm going to show the embedded log. And with this, you basically just have to set things up. Make sure that the arrhythmia is the data table that's of choice. So this is the data table it's working on. All right, and then right click and run the script. All right, so now we have the data frame, and we've got that all set up, and then you can go on and do further analysis. So that's everything in a nutshell. There are some other things that I'm going to show you that make this a little bit easier in JMP. So you wouldn't have to just take that data as is in JMP and then, or delete data and find your outliers and go from there. So basically what I'm trying to say is I'm going to show you some other types of analysis. And let's go to Analyze, and we're going to go to Screening, and we're going to explore outliers. All right. So I'm going to grab a bunch of columns here, put those in Y and say OK. And now we're going to look at something called quantile range outliers. You have some other univariate fits and then multivariate fits that will help you find these outliers if you so choose. But this is the easiest and the fastest. We're going to be looking at the upper and lower 10% of the data. And then with our Q value here, it's kind of like looking at 3 sigma, or it's the value of 3, but we're looking at 3 times past the upper limit and 3 times past the lower limit. All right, so that's where we're looking at. And if you look down here, we have some potential outliers. Let's just say, let's look at only the columns that have potential outliers. And you know, some of these are close to being right on the, or they're right on the cusp of the upper and lower ranges of these. So if you look at the high threshold for QRS duration is 187. We've got a point at 188. Is that really an outlier? Probably not. So we can manipulate that a little bit. Say, let's go with 5 on a Q value. So we're going to spread out that range. We're going to look out a little farther on both ends. And then, okay. And then we'll rescan. And lo and behold, we have one row or one column that has 2 potential outliers. So that's how you would do that in JMP, right? And then you could go back and then actually exclude those rows, select them, color them, whatever you need to do, but make the change as you need to clean up the data to send it to Python. All right, so we're just going to leave that as is for now, right? And then we're going to go back to our arrhythmia table, go to Analyze, Screening, and Explore Missing Values, right? Same thing as we did before. We're just going to pull up the same columns and look for some missing values. And just like we had before, we have a bunch of columns that don't have any missing data, but some that do. So we're going to show only the columns that have the missing data. And now you get to choose what type of modeling do you want to use to find out if you wanted to do some imputation. So just a little bit of a caveat here, or a little watch out, is that we're looking for, the only reason we're looking to impute data is to see what would happen if we had that data available to us in any other modeling step, so, or any other analysis step. So the whole idea is that you don't want to put in data or impute data and keep it in there. All you're doing is imputing the data and then checking to see if, you know, if you actually had it, how things would turn out, and maybe that'll convince you that you need to go get that data. Okay, so the other thing to point out here is that you may find columns that have more missing data than anything else. So what would be nice is just to get rid of that column. It's not going to be used in the analysis because it has more missing rows than it has data. So there's no reason to try and even impute values for that. So we can actually do that. But what we're going to do is just select these columns that have just a few missing values, and we're going to impute those. All right, so we're going to use this multivariate normal imputation, which builds a model across all the columns to see what values we're going to put in there. So it says yes with shrinkage, so their data is changed. And so if we go back to the data table, we now have where we have missing values, like for heart rate, you can see that 75.321, that's in there. And if we go down further, we've got some other rows that have that. So that signifies that this is imputed data and not data that's originally associated with the data table. So that's a good way, or an easy way to do that. So let's clear out all of these selections. All right, and then what we're going to do is we're going to go to this other data frame, or this other Python script, and we're going to do the same thing as we did before, but this time we're going to find both the outliers, potential outliers, and the missing values using a script. We're going to send the data to Python and let Python do the analysis for us. So we've got our data, our script up. We've got our embedded log showing. So let's go ahead and run the script. and it opened the data table again. So that's the first thing you're going to see. So let's go back to our script, and it's already done. So it's found, I don't know if you remember, but with the missing values, we had J had 376 and heart rate 111. So it did a good job of finding the missing values. Now, the story is a little bit different for the outliers. We have virtually every column has potential outliers based on the calculation that was done for determining outliers in Python. Okay. So with that, we'll stop there, and just remember that it's not always the using Python is not always the easiest way to do something, right? Because you're going to have to code. Jump can help you get to someplace faster, and then allow you to do some further analysis with your data. So thank you.